Question 7, consider the polynomials given below. So we've got the two polynomials p and q. Determine the operation that results in the simplified expression below. So we've got some work to do, but the first thing I notice is this answer has an 11x to the fifth, and so does p. So that means q is probably, more than likely, is not going to have an x to the fifth in it, which means we're going to be adding or subtracting p and q together, and there will be nothing that combines with 11x to the fifth. So it's probably not going to be this last choice. Very unlikely. And the fact that that's the only one that calls for multiplication is a further clue. That's not going to be it. It also means it's probably not going to be this one, q minus p, because this means we would be subtracting this term, and it would become negative 11. So it's also probably not this one. So, and again, you don't have to make that deduction at all. We can just do the math. But the first thing that I want to take care of is I want to take care of these two binomials and multiply them together. So 2x squared plus 1 multiplied by 4x squared minus 3. Distribute the 2x squared. So that's 8x to the fourth minus 6x squared. We're going to distribute the 1. 1 times 4x squared is 4x squared, and 1 times negative 3 is negative 3. My like terms are here in the middle. So we have 8x to the fourth minus 2x squared minus 3. So this is my new q. So I'm going to mark out this q. And let's check. So let's check this first one, p plus q. We already know if we do p plus q, 11x to the fifth, there's no other x to the fifths in the q equation. So that checks out. Put a little check mark there. Let me not do a circle and just do a check mark there. I'm going to delete that one. Okay, next we have 9x to the fourth. That will combine with 8x to the fourth. 9x to the fourth plus 8x to the fourth is 17x to the fourth. That does not match there, which means it is not this choice. Okay. So now let's do p minus q. So p minus q, we're going to take 11x to the fifth, that's in p, and we're going to subtract from it nothing, right? Because there are no other x to the fifths. So this still checks out. Then we've got 9x to the fourth minus, because we are subtracting q, 9x to the fourth minus 8x to the fourth. Or in other words, 9 minus 8. 9 minus 8 is 1, and that's what we've got here. We got 1x to the fourth. Let me pick a different color. Negative 4x to the third minus, there are no other x to the thirds, so that's why this checks out. Negative 7x squared minus 2x squared, well, negative 7 minus, we got to be careful here. I've made a mistake. So it's negative 7, but then we've got to take the minus sign, because there's a minus sign in between p and q, and we're going to minus or subtract the negative 2. So negative 7 minus negative 2 is the same thing as negative 7 plus 2, which is negative 5, and that's where that negative 5x squared is coming from. And then very similarly, positive 5 minus, because it's p minus q, negative 3. 5 minus negative 3, those double negatives turn to a positive, and we get positive 8. That checks out. So this is our answer, P minus Q.